Have you ever hit that, like, mid-afternoon wall where you look at your computer screen and genuinely forget what language you read?
Oh, yeah.
Your energy falls off a cliff, your brain turns into a lukewarm oatmeal, and the only coherent driving thought you have is, I need something salty, I need chips, immediately.
Right. Or maybe the symptom isn't the crash, but it's this constant state of sort of low-grade misery.
Yeah.
You're chugging water all day long, yet you spend half the night running to the bathroom, convinced you suddenly have the bladder of a small child.
Exactly.
Yeah.
So what if the reason behind that persistent thirst, that sudden onset fatigue, and those like aggressively intense cravings for salty carbs wasn't some random issue of aging or, I don't know, poor discipline, but something infinitely more common and actually entirely fixable?
Well, today we are diving into the hidden signals, what we're calling the stealth saboteurs, that your body sends when its entire fuel system is kind of out of whack. We're focusing on the surprising symptoms that point straight to a chronic blood sugar problem, specifically insulin resistance, even if you've never been diagnosed with anything like that at all.
And what's crucial to understand here, I think, is that the problem isn't usually feeling the high blood sugar itself, not unless it's, dangerously high.
Or maybe just fatigue them.
Yeah, the real trouble and the source of all these annoying symptoms, it starts when the primary regulator hormone insulin stops doing its job effectively.
That's the key. When insulin stops working, or, when the sugars crash too low in response to an insulin spike, that's when the body goes into full crisis mode. It's signaling starvation and toxicity at the same time.
Okay, let's unpack that core mechanism then, because it really explains everything that follows. Insulin is often described as the key, right?
The key.
When you eat carbohydrates, sugar glucose enters the bloodstream. Insulin's job is basically to grab that key and unlock the cell door, the receptor, to let the sugar in for energy. Simple enough.
Seems simple, but imagine you hit that lock with the key too many times a day, every single day, maybe for years. The cell eventually just becomes deaf to the signal. It develops insulin resistance.
Okay.
So the key, insulin, stops fitting the lock properly. The fuel, the glucose, it just piles up outside in the bloodstream like a massive traffic jam on the freeway. But the cell itself is starving because it can't get the fuel in.
Wow. That's the ultimate paradox, isn't it?
Right.
You have energy floating everywhere in your blood, but your cellular battery is just dead.
Exactly.
But if the cells are starving, why doesn't the body just compensate? Like, why not create more insulin to try and force the door open?
Well, it does initially. Your body's smart, right? So it floods the system with even more insulin, trying really hard to overcome that resistance.
Okay.
But this just makes the problem worse over time because now you have two problems: high glucose and chronically high insulin.
Double trouble.
Yeah. So the symptoms we feel are the body either desperately trying to dump that toxic excess sugar, or it's the cells signaling their absolute starvation for fuel, one or the other, or both.
Okay, let's look at how this actually manifests then. The first stealth saboteur you mentioned is excessive urination. Why are you getting up multiple times in the middle of the night? We're talking chronic, frustrating sleep interruption here.
Yeah, it's often the very first indicator that something is fundamentally wrong with glucose management. When sugar concentration in the blood gets too high, the kidney has to filter that excess sugar out into the urine.
Right.
And basic biology, wherever the sugar goes, water follows. So the kidney is acting like this frantic janitor, just dumping sugar and water, because that high concentration of sugar is literally toxic to your system.
Which naturally leads to sign number 2, excessive thirst. I mean, it makes sense. You're already losing massive amounts of water from the overnight urination.
Right, but it gets a bit more complicated because of salt.
Salt. How does salt get involved?
Well, high insulin levels actually tell your kidneys to hang on to sodium. So now you've got high sugar and you're retaining sodium.
Oh.
To dilute this really highly concentrated mix of sugar and salt, the body demands more water. So the result is chronic dehydration no matter how much water you actually drink.
Wow. And I remember reading something about this process often leading to a deficiency in another critical electrolyte.
Yeah.
Potassium. Why does losing potassium matter so much?
Well, if you're retaining sodium because of the insulin signal and then you're losing excessive fluid through urination, you basically throw the entire electrolyte balance completely out of whack.
I see.
Potassium deficiency, which is very common in this state, leads to all sorts of systemic issues. Things like heart rate spikes, poor sleep quality, unstable blood pressure. It's all connected back to the kidney trying to manage that sugar crisis.
Okay, that makes sense. Let's move on to sign 3, which is one you can actually see. Skin changes.
Yeah.
You said to look for dark, almost velvety patches in the folds of your body.
Yeah, specifically the neck, like the back and sides of the neck and underneath the armpits are the most common spots. It's called acanthosis nigricans. Those darker, sometimes thicker folds are literally a visible physical sign that you have elevated insulin levels and underlying blood sugar issues. It's the resistance showing up on your skin.
A literal manifestation.
Okay.
And the fourth sign is perhaps the most frustrating one for many people.
Yeah.
Brain fog and fatigue.
Mm-hmm.
You know, you're lethargic, you can't think straight, and you probably just assume you need more caffeine, or maybe you're just getting old.
Yeah, and the irony is just crushing. You're foggy because your neurons are starving for fuel, even though there's glucose floating everywhere in the blood.
Mm-hmm.
It's exactly like having a full gas tank, but the key to the ignition is somehow stuck or broken. Your brain cells simply are not receiving the energy they desperately need.
That implication is huge, though. So we could be talking about serious cognitive decline, maybe the early stages of what could lead to dementia being essentially a fuel delivery problem, not just an age problem.
Yeah.
It's kind of revolutionary.
That's exactly what the science is suggesting now. This state of persistent neuronal starvation, specifically due to insulin resistance, seems to be the foundational mechanism behind many forms of cognitive decline.
Wow. That really reframes everything. Okay, let's talk about sign 5, mood swings. That classic hangry feeling.
Oh, yeah.
The person who is highly irritable or maybe experiencing more generalized mood disorders
Yeah.
is that often someone whose blood sugar is spiking way too high and then crashing way too low because of this whole malfunctioning insulin system.
Absolutely. If we look at the bigger picture, it strongly suggests that many emotional or mental health issues could actually be rooted in metabolic instability. I mean, imagine if someone who is really struggling with mood disorders could stabilize the fuel supply to their brain just through diet. Some researchers suggest that maybe 80 to 90% of certain mental problems might be mitigated just by eliminating those extreme spikes and crashes.
That is such a powerful argument for starting with the plate, isn't it?
It really is.
Now, for the symptom we all know too well, sign 6, those intense cravings. And you mentioned it's not just craving sugar, which seems obvious. It's specifically salty carbs, like potato chips.
Absolutely. The body gets stuck in this immediate gratification mode. The cells are starving right now, so the body asks for the quickest possible fix, which is usually sugar or carbs.
Okay.
But because you're already likely depleted of electrolytes like sodium due to all that urination and fluid dumping we talked about.
Right, the thirst mechanism.
Yeah. So the body is also demanding sodium. You end up with this desperate demand for the worst possible combination. Quick glucose delivered with massive amounts of salt. You're feeding the craving, not fixing the underlying mechanism.
Just digging the hole deeper. Okay. And finally, sign 7, blurry eyes. How does that happen?
Well, the lens of the eye, the part that focuses your vision, it can actually get swollen and fill up with fluid because of the chronic high sugar concentration in your body fluids. And it isn't just a temporary vision problem either. Over time, the inner eyelid can get red and inflamed, and it can feel exactly like there is sand in there. It's just another clear sign that excess sugar is physically altering the environment within your body.
Okay, so we've identified 7 pretty clear distress signals, from that weird chip craving to your darkening armpits, even blurry vision.
Yes, sneaky saboteurs.
Right. But if traditional medical approaches often teach patients to merely manage the symptoms, take this medication for the sugar, carry candy for the inevitable low-sugar crashes, we clearly need to address the root cause, the fuel resistance itself. So let's talk solution.
Well, if the core problem is glucose overload, the logical answer is to switch the body's primary fuel source. We want to lower the glucose so drastically that the body automatically switches to burning ketones instead.
Ketones.
Which are a clean, really steady source of energy derived from fat.
Okay. And how do you make that essential fuel switch happen?
To make it happen, you have to drastically lower your carbohydrate intake. The general guidance is usually dropping below 50 grams per day, but ideally you'd aim for around 20 grams to reliably trigger that ketone burning state, ketosis.
20 grams. That's quite low.
It is, but it's effective for breaking the cycle. And importantly, that low-carb approach has to be paired with adequate protein.
Protein? Why protein specifically?
Because we need to stimulate the hormone that does the opposite of insulin. That hormone is called glucagon.
Glucagon.
And glucagon is triggered by high-quality protein things like red meat, fish, eggs. So this protein intake, combined with the very low carbs, helps rapidly stabilize blood sugar and bring down that hyperactive insulin signaling.
Okay, that sounds pretty straightforward, actually. Lower carbs, adequate protein. But let's talk about a potentially confusing diagnostic step, the A1C test. People rely on that.
Right. The A1C is a crucial tool, no doubt. It measures your average blood sugar levels over a period of about 120 days, roughly 3 months.
How does it work?
It works by calculating how much protein, specifically hemoglobin in your red blood cells, is glycated, which basically means coated with sugar. The higher the percentage on the test, the higher your average sugar exposure has been over that time.
Got it. So here's where it gets really interesting and frankly counterintuitive for anyone who makes this dietary shift you're describing. When you switch to a very healthy low-carb diet, you might actually see your A1C results stay the same or even go up slightly. That could totally panic a patient or even a doctor who isn't familiar with this.
Exactly. And it's so critical to understand why this happens. It's actually often a sign of better health, believe it or not worsening diabetes.
Better health with a higher A1C. How?
Okay, so when you adopt a really healthy low-carb diet, you're often improving the health of your cells, including your red blood cells. You can actually extend their lifespan. So instead of living for a standard 120 days...
Which is what the A1C calculation is based on.
Precisely. Instead of 120 days, they might now live for 130, 140, maybe even 150 days because they're healthier.
I see. So a longer lifespan means those individual red blood cells have more time floating around to gather that sugar coating, even if your day-to-day blood sugar is actually much lower and more stable.
You got it. More time equals potentially more glycation per cell, which throws off the standard A1C formula slightly. You're improving your health by making your cells more robust and longer living, but the test score might look static or slightly worse because the measurement window for each cell has fundamentally changed.
It's fascinating. So it's the formulae that's the issue in that context, not necessarily your underlying condition.
Exactly. That robust, longer-living red blood cell is actually a sign of systemic improvement. And it's crucial information every doctor needs to know when they're reviewing A1C results for patients on a low-carb or ketogenic diet. Context matters.
Absolutely. Okay, so let's bring it all back together then. We covered 7 pretty sneaky symptoms, from that desperate urge for a bag of chips to fluid loss issues, visible skin changes, brain fog, all pointing back to one central issue: insulin resistance and the resulting cellular starvation.
Yeah, the stealth saboteurs making you tired, thirsty, and craving chips. And if the traditional approach often teaches patients just to manage chronic illness, take a pill for the sugar, take another pill for the blood pressure it causes, what foundational understanding are we maybe missing about health itself?
Right.
If changing the fuel source, simply altering your diet, can potentially resolve these 7 distinct issues in just a few weeks or maybe a month for many people. Are we accidentally normalizing a state of just managed sickness instead of pursuing true radical resolution?
It's a big question, and definitely something for you, the listener, to mull over. What other annoying symptom are you currently just managing, just putting up with, that might actually be a desperate cry for help from your starving cells?